Hello, and welcome to 5 Minute Math. Today, for our number talk, we're looking at these two mixed numbers and trying to decide if the difference is going to be less than 1 or greater than 1. So first, let's look at our whole numbers here. We got a 6 and a 5. And so hopefully we immediately think, well, if I just look at the whole numbers, right, 6 minus 5 is going to be 1. So my answer is going to be about 1. But the question is it less than 1 or is it greater than 1? And that's where we really have to end up looking at our fractions. And so if the 4/5 happens to be a little bit larger and the 9/12 happens to be a little bit smaller, well, when you take a smaller fraction from a larger fraction, you have a little bit left over, right? And that's going to end up being greater than 1. But if it's the opposite, if this ends up being a little bit smaller and the 9/12 happens to be a little bit larger, well, when you do that, you end up having to regroup when you take a larger from a smaller, which means we're not going to have a full 1 as a whole number, and we're going to be a little bit less than 1. So that goes down here and this goes up here. Let's see what we can figure out about 4/5 and 9/12. If we wanted to, we can generate equivalent fractions, but there's going to be a little bit easier way to do this. Hopefully we're looking at 9/12. And rather than finding that common denominator, we're thinking, you know what, we can simplify that, right? Always be looking at a fraction thinking, can you simplify it? Yeah, we could divide both numerator and denominator by 3. So 9 divided by 3 is 3, and 12 divided by 3 is 4. Okay, so now I've got 4/5, and let's just call this 3/4. Hopefully, at this point, we're thinking, oh, these are both benchmark fractions. We should know decimals, percents based on this. This is one way to solve this. So most of us know 3/4. That's like 3/4, right? That's 0.75 or 75%. Now, what do we know about fifths? Each fifth is worth 0.2, 0.20. So 20, 40, 60, 80. So this is worth 80%, or if you want to put it as a decimal, 0.8. Since that goes to the hundredths place, I'll make it 0.80. So now we can evaluate, say, oh, the 4/5 is a little bit larger. Another way we can evaluate this is, look, 4 is only 1 away from its denominator. 3 is only 1 away from its denominator. Okay? So look what happens when we shade fractions. If I were to take 1/2 and I were to take 9/10, well, we know that this 9/10 is going to be much larger. But look, it's only plus 1. They're only one difference away. So since another way we can evaluate this is as the fractions get larger, as long as the numerator stays just 1 away from the denominator, the fractions are going to get larger and larger. Because imagine if we had 9/10, and then imagine if we had 99/100ths. Well, that's going to be larger than the 9/10. So as the denominator gets larger, if the numerator is just 1 away, you can compare that way as well. Both of them give us the same answer, that this 4/5 is going to be just a little bit larger than that 3/4. It's 500ths away, which means when we subtract a smaller fraction from a larger fraction, there's a little bit left over, and ultimately it's going to be a little bit greater than 1.